In this video, we will discuss about thermal conductivity. Thermal conductivity of a material is defined as the amount of heat flowing per unit time through unit area of cross section of the material maintained at unit temperature gradient. K is equivalent to minus Q by dt by dx, watt per meter per Kelvin. The negative sign indicates that heat flows from hot end to cold end. In general, the thermal conductivity of a material is due to the presence of lattice vibrations and electrons. Hence, the total thermal conduction can be written as K total equivalent to K electron plus K phonons. The amount of heat conducted by the rod from the end A to B of length 2L or 2 lambda is given by Q dash is proportional to A into T1 minus T2 into T divided by 2 lambda, where K is coefficient of thermal conductivity, A is area of cross section of the rod, 2L is the length of the rod, that is 2L or 2 lambda is the length of the rod, T is time for conduction. Q dash is equal to K into A into T1 minus T2 into T divided by 2 lambda. Amount of heat conducted per unit area per unit time, Q is equivalent to Q dash divided by AT. T1 minus T2 equivalent to temperature difference between the ends A and B in terms of Kelvin. We can write the coefficient of thermal conductivity per unit area per unit time K is equivalent to Q by T1 minus T2 into 2 lambda. Since each electron travels with thermal velocity V, and if N is the 3 electron density, then on an average 1 by 6 NV electrons will travel in any one direction. The number electrons crossing unit area per unit time at C is 1 by 6 into NV. According to kinetic theory of gas, free electrons are assumed to be gas molecules which are freely moving. The average kinetic energy of an electron at hot end A of temperature T1 is equal to 3 by 2 kb into T1. The average kinetic energy of an electron at cold end B of temperature T2 equal to 3 by 2 into kb into T2. The heat energy transferred per unit area per unit time from end A to B across C equal to number of electrons into average kinetic energy of electron moving from A to B equal to 1 by 6 into NV into 3 by 2 kb into T1. That is equivalent to 1 by 4 NV into kb into T1. Similarly, the heat energy transferred per unit area per unit time from end B to A across C equal to 1 by 6 into NV into 3 by 2 kb into T2. That is equivalent to 1 by 4 into NV into kb into T2. The net heat energy transferred from end A to B per unit area per unit time across C can be got by subtracting equation 5 from 4. Q is equivalent to 1 by 4 into NV into kb into T1 minus 1 by 4 NV into kb into T2. Q is equivalent to 1 by 4 NV into kb into T1 minus T2. Substituting equation 6 in equation 2, we get K is equivalent to 1 by 4 into NV into kb into T1 minus T2 into 2 lambda divided by T1 minus T2. K is equivalent to NV into kb into lambda divided by 2. We know that relaxation time equivalent to collision time for metals. Tau is equivalent to tau C, that is tau into V equivalent to lambda. Substituting equation 8 in equation 7, we get K is equivalent to NV kb into tau V divided by 2. Thermal conductivity K equivalent to NV squared kb into tau by 2. Equation 9 is the classical expression for thermal conductivity. Thank you.